start. If my calculations are correct, it is now precisely October 21st, 2015. The future has finally arrived. Yes, it is different than we all thought. But don't worry. It just means your future hasn't been written yet. No one's has. Your future is whatever you make it. So make it a good one.
Alright guys, hopefully I'm not the only one that just heard that video and almost had a tear in your eye. Somebody help me out here. But no, I thought that was a neat little video there. It was Doc Brown from Back to the Future. And if you guys have ever watched Back to the Future, great movie, but it's such a good message. It really is. The future is yours to make of it. So, make the most of every day you can, but you get the idea. So, alright, welcome back, or welcome. Order real numbers and simplifying square roots we're going to take a look at today. Now, the links are online. Please realize that there are some additional links in all of these pages that will help you if you would like additional support. This is for you guys to take a look at. So, without further ado, here we go. What is the difference between rational and irrational? A rational number is any number that can be written as a fraction. So, you're looking at numbers like 1/2, okay, 1/3. Technically, any whole number works as well. You could have 5, -2, so on, okay. Okay, and then you could have literally any integer. You could have your whole numbers, so on. Okay, so rational is a whole spectrum of numbers. The one important thing to point out is that rational could be a repeating decimal. Like if you look at 1/3, it's 0.33 repeating. All right, so you can have repeating decimals here. Irrational number is a number that cannot be written as a fraction. An example of this, hopefully you guys all remember this symbol, pi. All right, 3.141592653759732516593. I'm just messing with you. I know 3.14. But, it keeps on going forever and ever and ever, okay? Same thing with square roots of non-perfect square numbers. So, like square root of 3, that's irrational, okay? If we take a look at square root of 3 in your calculator, super quick, we get 1.732050808. Just notice how there's no set pattern as you go across, okay? So, when comparing rational and irrational numbers, your best bet is to convert them into decimal approximations and then compare. So compare the following real numbers using inequality symbols, less than, greater than. For number 1, part A, 5's good. Square root of 28. Again, you have your calculator here. We can do second square root, 28. And we get 5.29. So if I had to compare these two, which one would be bigger? Hopefully you guys can see 5.29. This is your tenth and hundredths place. This should be bigger. Boom. You're in good shape. Okay. Let's do one more of these, and I can let you guys work on the rest of them. Just to show you guys, let's go with part D, just so you guys at least see this. Ooh, I don't know what happened to the light here all of a sudden. Went away. No, come back. Yeah, I'll take it. Okay. So for D, you see this letter E here? This is called a natural number E. It's actually on your calculator. If you hit second and then the division sign, it pulls up E on your calculator. Oops, I'm sorry, I hit alpha. Second and then division sign. And you can raise that to the 5th power. We get 148.41. And then for the second one, 189 divided by 1.24. 152. That makes that a little bit easy to see then. Alright, so we can say e to the 5th is less than 189 divided by 1.24. Alright. And you can check out the rest of these if you want to see any answer keys. By all means, feel free to ask. Now, list in ascending order, least to greatest. Let's take a look at one of these together. Ascending order is from least to greatest, so negative pi would be negative 3.14. And just notice, I'm going to do a lot of pre-work, if you will. I'm going to do a lot of setting these problems up. Root 5 plus 2. Root 5 plus 2. Make sure that your plus 2 is outside of your radicand. Hit enter. 4.23. 3 raised to negative 2 power. 0.11111 repeating. 3 root 12. 10.39. And then negative 2 root 6. Negative 4.89. Okay, so I got all my numbers here. Let me zoom in here for 1 second. I'm clicking a little bit here. maybe, there we go. Now, the smallest one, least to greatest. Okay, your smallest number here, obviously the negative's going to be first. Hang on one second, focus. I don't know why it's bothering me. Sorry. Okay, your smallest one's going to be your negative 4.89. So we're going to put that first. Negative 2 root 6. Cross that one off. Then I've got negative pi. Cross that one off. Okay. Let's see here. Then I've got 0.11 repeating, which is 3 to the negative 2 power. Cross it off. You got root 5 plus 2. Cross it off. And then lastly, 3 root 12. You're all good. Okay? So wonderful. And you can take a look over here as well, another example, and please check your answers in the front of the room. Okay, number 3 is much the same. It says, which of the following numbers is not listed in ascending order? It's the exact same problem up here, except that keyword being not. One big thing for this keystone, make sure you're reading directions. If you'd like to see the answers to this, we will post the answer key, no big deal. But again, you are just putting everything, converting it, and checking it out. Okay? So, we're going to move on to the back page. Square roots. Now, a value that, when multiplied by itself, gives the number. 4 times 4 equals 16, so the square root of 16 is 4. Alright, so it says here, find the product without a calculator. I'm just going to do 1 or 2 of these. Hopefully you guys are comfortable with these. 3 times 3 is 9. 8 times 8 is 64. The other one I want to point out to you is over here, the very last one. What is negative 4 times negative 4? Positive 16. Very good. Okay. Now, evaluate the following perfect squares without a calculator. Alright, so, oh, by the way, please try the ones up here that you haven't tried out. So square root of 4 is 2. Square root of 16, 4. Okay, you can see how we're going with this. Check out part E, root 4 over root 9. You can do each one separately. Root 4 divided by root 9. Square root of 4 is 2. Square root of 9 is 3. 2/3. Very good. Alright, now, the square root symbol is known as the radical, and the value that you are taking the square root of is known as the radicand. Okay? The imaginary 2 is called the index. In the problem below, identify the index and the radicand. So, the index is this number that's outside here. Now, for all your square roots, for all your radicals, what you're going to see is not the 2 written there. Alright, like, you know, it's because we use them so very much. Now, you will see it for cubed root, fifth root, so on. Alright, just be aware of that. Now, when you're breaking things down, we can rewrite the product of 2 or more square roots as the square root of the product of the radicands in simpler terms. Root 8 times root 8 is root 64. Alright, and you can keep going with this. Root 2 times root 6 times root 3. You can multiply the numbers underneath there to get root 36. Right? So, simple enough. You can multiply things underneath there, okay, underneath your radical. Multiply the following square roots to find the exact product. Now, when they say the exact, they don't want a decimal approximation. They want, like, broken down terms. So, for the first one, root 7 times root 3, they're both under the radical. So what you can do is 7 and 3 gives me 21. There we go. Now, you want to look to try to break these down if you can. In this case, you can't, meaning no perfect square can go into it. There you go. Take a look at your second one. Right? Root 21 times root 3. So again, I can multiply these two things because they're both under the radical. We get root 63. Now, what you can do, and we're going to talk about down here, is you can simplify down these square roots. You are looking for perfect squares. I'm going to write them over here to the side for you. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, so on, so on, so on. You're looking for one of these numbers that can evenly go into the number under the radical. Okay? After a little bit of sleuthing around, you can find that 9 can go into 63 7 times. So we can break this down to be root 9 times root 7. Ladies and gentlemen, what's the square root of 9? 3. The square root of 7 stays the square root of 7. That is irrational. Okay? But you leave it there in the end tacked on. Okay? Awesome. So we're going to jump down here for the last few. We're going to do a few problems to kind of help you guys out. Maybe do 1 or 2 and see where we're at. But simplify the following square roots. So when I look at something like letter A rather, okay, you have square root of 72. and you're looking for the largest perfect square that can go into it. In this case, we can have 36 go into it 2 times. All right, now what you could do is a little calculator trick. 72. Find the number over here. Okay, like the number beneath 72. So in this case, it's 64. You could try dividing by 64. It won't go in evenly. So try your next one. 49. Okay. And you can keep going through this, and then, 36 and 2. That works. All right. The square root of 36 is 6. Root 2 is just root 2. Boom, done. All right. Just going to jump around a little bit. Let's see here. Let's try out letter C. Root 48. What perfect square? Again, the perfect squares are right here. Can go into 48. 16 and 3. Just keep trying till you find numbers that work. What's the square of 16? 4. There we go. Looking good. Okay. Let's see here. Try out part F real quick. Notice how there's a negative sign out front. You can let the negative sign chill out front. What perfect square goes into 50? 25 times 2. And then I got the square root of x squared back there. We're going to talk about that in just a moment. What's the square root of 25? 5. And then I got my root 2. Ladies and gentlemen, the square root of 2, the number that you have out here, like we talked about up top here a little bit, is like an imaginary 2. Okay? So, when you have an even number for your exponent for your variable, what you can do is you can do 2 divided by this imaginary 2 here. What's 2 divided by 2? 1. So, we can actually pull this out and get negative 5x root 2. The square root of x squared is x. The square root of x to the 4th is x squared. The square root of x to the 6th is x to the 3rd. The square root of x to the 8th is x to the 4th. Yeah, I hope you're seeing where I'm going with this. You're just dividing by 2 each time. Okay? I think that's about good for right now. You can try out the problems you're missing. All right. If you have any questions about anything else, please feel free to ask. And of course, we have the answer keys up in the front of the room. You may always check them out. But keep up the good work. All right. And as always, good luck. We're all counting on you.